Welcome back, students. In this session, we will learn the remaining properties of rational numbers. So let's start with this one, multiplicative identity. Now, multiplicative identity of a rational number is a number by which you multiply your rational number and it does not change the rational number. For example, if I have a rational number A and you multiply it by something and I get the same number. So what is that number? So the number is 1. So when you multiply any number by 1, or you multiply 1 to any rational number, the answer is same. It doesn't change my rational number. It is not changing the identity of my number. So the number 1 is known as my multiplicative identity because it is not changing the identity of the number on multiplying. Now let's come to additive identity. Now, which number when added to a number is not changing the value of the number? So A plus which number will give me the same answer A? So the answer is 0. So A plus 0, or you add 0 plus A, the answer is A. So 0 when added to my rational number is not changing the value of my rational number. So 0 is known as my additive identity because 0 is not changing the identity of my number. So 1 is the multiplicative identity and 0 is the additive identity. Now, multiplicative inverse. Suppose we have a number A which is not equal to 0 and A times 1 upon A. The answer is 1. So we say A and 1 upon A are multiplicative inverse of each other. The one more name for multiplicative inverse is reciprocal. Now, to find the multiplicative inverse, what you have to do is simply flip the fraction. You have to simply flip the number. So, let's look at some example. So, if I want to find multiplicative inverse of 3. So, to find the multiplicative inverse, you will flip the number. So, 3 means 3 upon 1. So, when you flip, you get 1 upon 3. Now, one more point what you should know is the sign of the numerator and denominator. Suppose I have a number here, A upon minus B. Now we do not write the denominator negative. So the minus sign can be written in the numerator. How it goes to the numerator, you can see here. So you can multiply both by the same number, minus 1, multiply both numerator and denominator. A into minus 1 is minus A, and minus into minus will become plus, B into 1 is B. So you can see here the minus sign which was in the denominator, now it has moved to the numerator. So the sign in the denominator is negative, I can simply write it in the numerator. At times you can see that the sign, instead of writing with the numerator or denominator, it is written for the whole fraction. So it is written like this, minus A by B. Very important. Okay, let's have a look at some more examples now. I want to find inverse of 2 upon 5. Multiplicative inverse of 2 upon 5, you need to simply flip it. So 2 by 5 is 5 over 2. Now, I want minus 7 upon 3. So, students, they feel the answer should be 3 upon minus 7, which is in a way correct, but not in the standard form. So 3 upon minus 7, you are simply flipping it. But as I told you, we do not write the denominator negative. So this number will become minus 3 over 7. So the minus sign stays, you simply flip the number. Now the number 0 has no reciprocal. So we don't have multiplicative inverse of the number 0. So 0 has no multiplicative inverse. What is multiplicative inverse of 1? So you flip 1, you get the answer 1. Multiplicative inverse of minus 1. So minus 1. So minus 1 is minus 1 upon 1. So you will get 1 upon minus 1, so which is again minus 1. So multiplicative inverse of 1 and minus 1 are the same number. So they are multiplicative inverse of, they have the same multiplicative inverse. So 0 has no multiplicative inverse. 1 and minus 1 are numbers which have their own multiplicative inverse. So they are multiplicative inverse of itself. Okay. Now let's come to the next one. Additive inverse. If a sum of two numbers is 0, for example, we have A and minus A is 0, that is same as minus a plus a, the answer is 0. If sum of two numbers gives you the additive identity, then the two numbers are said to be the additive inverse of each other. Now to find additive inverse, what you have to do is simply change the sign. So to find additive inverse, change the sign of the number. Okay, for example, if I have 3 upon 7, so the additive inverse of 3 upon 7 is minus 3 upon 7. I want to find additive inverse of minus 5 upon 8. The additive inverse of minus 5 upon 8, just change the sign. So minus 5 upon 5 by 8, additive inverse will be 5 over 8. So additive inverse, you have to change the sign. Multiplicative inverse, you need to flip. Now, coming to the last property, which is a distributive property. Suppose we have three rational numbers a, b and c. Then, if I have a times b plus c, okay, you can distribute a to a and c, which is also known as expanding the bracket. So, you get a times b and a you multiply to c plus a times c. So basically you are expanding the bracket. This property is known as distributive property of rational number of multiplication over addition. So we are distributing multiplication over addition. If you have subtraction here, you will say it is distributive property of multiplication over subtraction. Now in practical examples, we will be doing the reverse. Okay. In practical examples, we will be doing reverse, which is known as factoring. Okay. Now, let's start with the examples. Let's have a look at the first example. Now, coming to the first example, question says, using distributive property, evaluate the following. Now, before we start with the question, okay, I'll explain you one more thing. How to count the number of terms in the given expression. Okay. To count the number of terms in the expression. Now in the expression, the terms are separated by plus or minus sign. Either a plus sign or a minus sign. So now I'll write some examples. Let's count the number of terms. So I have here x square plus 5. So you can see here x square is my first term, then I have a plus sign, so the next term starts, and plus 5 is the second term. So I have two terms here. Pretty easy. Y square minus 2y minus 8. So let's count the number of terms. So y square is my first term, minus 2y is the second term, and minus 8 is the third term. So altogether here I have three terms. Let's look at one more example. X into x plus 4 into y into z minus 8. Now let's count the number of terms. So try to find out how many terms are there here. Just okay. Now some students will count 1, 2, 3, 4, 5, 6. No, it is wrong. It says the terms are separated by plus or minus sign. When it is multiplication or division, it is still one and the same. Now, these two are my first term because there is no plus minus sign here. The sign which is connecting the two x is multiplication sign. Here, then plus sign is there. Then my second term starts 4, y and z. All are in multiplication. So, these three together is my second term. And the last term is 8. So, I have altogether here 3 terms. So, first thing before you do such questions is you should know how many terms are there in the given expression. Now let's come back to our question. So now you can easily identify the terms in the expression. So 1 upon 5, 1 upon 2 is the first term. There is a minus sign. Now my second term is 1 by 5 and 3 by 2. Now look at both the terms carefully. Do you see any fraction or any number common in both? So you can say that 1 upon 5 is present in both. So what I will do is, I will factorize, I will borrow, I will remove 1 upon 5 common from both. So you will take common 1 upon 5 from both. So the circle number 1 upon 5 is removed common. So what am I left with? So from the first term, 1 upon 5 is out. You are left with only 1 over 2. Now, then this minus sign will be as it is. This 1 upon 5 which is circled is already removed common. So I am left with only 3 over 2. So we are using a distributive property in reverse, that is we are actually factoring. This is the most important step. Now let's simplify the bracket. Now if you see, one good thing in this particular question is the denominator is same, so you don't have to find the LCM, just subtract the numerator. So denominator 2 will be as it is, so numerator will be 1 minus 3. So 1 over 5 times 1 minus 3 is minus 2 and the denominator 2. 2 and 2 will get cancelled. So I get here 1 upon 5 times minus 1. So 1 upon 5 into minus 1 is minus 1 over 5. So this is my final answer. Okay. Now let's come to example 2. Okay. Example 2. Again, step 1 will be to identify the number of terms. So 8 upon 9 into 1 upon 2. This is my first term. Then there is a plus sign. The second term is 8 upon 9 times minus 1 upon 3. Now this minus sign is not connecting the two numbers. The sign which is connecting the two is multiplication. So these two together is only one term. Now, so we have only two terms here. So look for a number which is common in both. So if you see carefully, you can see that 8 upon 9 is present in both. So you can borrow 8 upon 9 from both. So if I take 8 upon 9 common, that is I am factoring. So 8 upon 9 from the first term is out. So what I am left with? Only 1 over 2. So I wrote the balance from the first term. Then there is a plus sign. So write here plus. This circled number 8 upon 9 is already removed common. So now I am left with only minus 1 over 3. So first step is to factorize. Now this plus sign and this minus sign will combine. So it will become minus sign here. So it is 1 upon 2 minus 1 upon 3. Now you need to simplify the bracket. If you see here, the denominators are not same. LCM of 2 and 3 is 6. Those who don't know to find LCM, you can do it orally like this. You start with the table of the big number. Always start with the table of big number. 3, 1 times is 3. Is this number 3 a multiple of 2? No. Then go for the next multiple. So 3, 2 times is 6. Is 6 a multiple of 2? Yes. So LCM of 2 and 3 is 6. So I need 6 in the denominator. The denominator should be like, only then we can combine. So to get 6 here, I will multiply by 3. To get 6 here, I will multiply by 2. So I get here 8 over 9. In the bracket, 3 times 1 is 3 by 6. This plus and minus became minus. So minus sign. 2 times 1 is 2 over 6. So 8 upon 9. Denominator is same. So you can subtract. 3 minus 2 is 1. And denominator 6 will be as it is. Now it is all multiplication. Now I can reduce 8 and 6 by dividing both by 2. So 2 3 times and 2 4 times. So this is the maximum I can simplify. So numerator 4 times 1 will be 4. Denominator 9 times 3 will be 27. So this is my final answer, 4 over 27. Let's come to the next example, number 3. Now step 1 is same. You need to identify the number of terms. So minus 2 upon 3 into 3 by 5. This is my first term. Then there is a plus sign. This 5 by 2 is separate. So this is second term. The third term is 3 upon 5 into 1 by 6. Now, so altogether I have 3 terms. Now if you see carefully, the second term there is only one number. So you cannot factor anything. So first step what I will do is I will rearrange the term. Now rearranging is known as associative property here. So my first term is same, minus 2 by 3 into 3 over 5. So I'll bring the third term in place of the second term. So it will have the same sign. So 3 by 5 into 1 over 6. And plus 5 by 2 I put in the end. So plus 5 over 2. So now my focus is only in the first two terms. We will keep the third term as it is till we simplify the first two. Now look at the first two terms. You will see that 3 over 5 is common in both. So we will factorize. So I'll get 3 over 5 common. So from the first term, you took 3 by 5 out. So you're left with minus 2 by 3. Minus sign will be as it is. From the second term, you remove 3 over 5 common. That is you factor. So you're left with only 1 upon 6. And you close the bracket. Now we are factorizing only the first two terms. The third term you will write as it is. Plus 5 over 2. Now look at the bracket. Now again we have the same numbers 3 and 6 here. Now the denominators are not same, so let's find the LCM of 3 and 6. Students normally think LCM means you simply have to multiply. 3 times 2 is 6. No, it is not that case. Now let's find the LCM. Start with the multiple of the big number. So 6 1 times is 6. Is it a multiple of 3? Yes. So LCM of 3 and 6 is 6, not 18. So I need a 6 here. So I'll multiply by 2, multiply by 2. Now 6 you already have, no need to multiply by 1. It's already 6. So simplify it further. So 3 over 5. You will get minus 4 by 6 and minus 1 upon 6. And plus 5 over 2 you will write as it is. Now, so you get here 3 by 5 times minus 4 and minus 1 will give me minus 5 upon 6. And this plus 5 by 2 will be as it is. Now, this is one term. Within a term, I can simplify it further. Now, this find the numerator, find the denominator can be cancelled. 3 and 6, you can divide by 6. So, 3 1 times, 3 2 times. So, what you are left with? So, you are left with, in the first one, you are left with minus 1 upon 2 and plus 5 by 2. I'll write it here. Okay. Now, are the denominators same? Yes. So, you can combine the numerators. So, minus 1 plus 5 whole divided by 2. So, 5 minus 1 is 4 upon 2. So, my final answer here is 2. Okay. Now, let's have a look at one more example. Coming to the last question, it says find 5 rational numbers between the following. Now, this particular question we can do by two ways. Let's look at the first method. Now, step 1 is to ensure that the denominators are same. If it is same, we can directly start. Now, you can see here the denominators of the two numbers are not same. So, again, we will make the denominator same. To do that, we will find the LCM of 3 and 5. So, LCM of 3 and 5, you start with the table of the big number. 5 1 times is 5. It is not a multiple of 3. 5 2 times is 10. Not a multiple. 5 3 times is 15. It is a multiple. So, LCM of 3 and 5 is 15. So, I need 15 as a denominator of both. So, now to make denominator 15, I have to multiply both by 3. And here to make it 15, I have to multiply by 5. So, I get here minus 3 over 15 and 2 times 5 is 10 by 15. Now, if you see here between minus 3 and 10, you have 5 rational numbers. So, you can see the numbers between minus 3 by 15 and 10 by 15 is. So, you can write minus 2 by 15, minus 1 by 15, 0 upon 15, 1 upon 15, 2 upon 15, so on till 9 upon 15. In case you come across a question where you don't have enough numbers between these two, then what you can do is you multiply both numbers by 10, 10, 10, 10. So then you will come to a situation where you have enough numbers between them. Now, second way of doing the same question is to find the average of the two numbers. So if A and B are two rational numbers, then you take the average or the mean. A plus B upon 2 is a rational number which is between A and B. So I need to find a number between minus 5 and 2 upon 3. So what you have to do is you have to add minus 1 upon 5 and 2 upon 3. This answer you have to divide it by 2 to get a number which is between these two. And then you have to continue the same pattern. Now, denominators are not same. So you have to do here is multiply by 3 and multiply by 5. Now, so you will get here minus 3 over 50 plus 5 times 2 is 10 upon 50. Now, when you subtract, denominator is same, 10 minus 3 is 7 upon 15. Now, dividing by 2 is same as multiplying by 1 upon 2. You flip the second number. Now you cannot simplify it further, so you get here 7 upon 30. Now this number 7 upon 30 is a rational number between minus 1 upon 5 and 2 upon 3. So you got one number here, 7 upon 30. Now you have to continue the same pattern. Now if you want to find a number in between here, so you will take the mean of these two. If you want to find a number between these two, you will take a mean of these two and continue. So this is a lengthy process. This is a faster way of doing it. Make the denominator same. If you have enough numbers between the numerators, you can directly write the answer. In case if you don't have enough numbers, suppose I had minus 3 here and I had only 1 here. So I don't have 5 numbers. So I'll multiply by 10, 10, 10, 10. So I'll come to a situation where I have enough numbers and you can list all the possible numbers. So for more such videos, do subscribe and like. See you.